So welcome again class sa subject natin differential equation. So for today, after 3 terms yung from prelim to semifinals, today is ngayon natin ma-appreciate yung mga pinag-aralan natin from prelim to semifinals, no? Kasi apply na natin siya sa practical application. Okay? So ito is observable siya sa environment natin, ano? Or sa paligid natin. Okay? So, sa applications of differential equations of order 1, so meron tayong tatlong i-discuss for this final lecture. So, today, yung first two lang muna yung di-discuss natin. Then, the last one will be sent to you maybe early next week, no? So, async na lang siya para yung remaining meetings natin will be focused on doing the project, no? So yung project is mag uh, mag magre-range siya hanggang 2 weeks siguro to finish. Okay, 2 weeks or 3 weeks to finish or yung before mag final exam, no? So again, that final project will be about applications ng differential equation. Okay? So yung details about that will be posted accordingly. But for now, we start with the discussion of the two applications of differential equation of order 1. Okay. So at the end of this lecture, these are the things that we hopefully needed to accomplish. No, need to accomplish. First one is to state and discuss yung formulas on heating and cooling, okay, and growth and decay. Okay. The next is yung solve tayo ng problems involving Newton's law of cooling. So yun yung tawag doon sa formula ng heating and cooling. Then yung sa growth and decay is growth and decay. Okay? So let us first start with Newton's law of cooling. Okay? In Newton's law of cooling, Newton states that the rate of change of the temperature of a cooling body is proportional to the difference between the temperature of the body and the constant temperature of the medium surrounding the body. Okay? So, ang ibig sabihin ng Newton's law of cooling, yung rate of change daw ng temperature ng body, okay? So yung rate of change ng temperature of a body, yung rate of change na yan is with respect to time. Okay? So kung i-denote natin na si T as yung temperature ng body natin, okay? And then is proportional daw siya sa difference between yung temperature of the body, which is yung T, and constant temperature of the medium surrounding. Okay? So yung kung saan nakalocate o yung sa environment, yung nakapaligid dun sa body natin. Okay? So tawagin nating M yung medium natin, ano? Medium surrounding. Okay? So from this law, we can get the formula para mahanap yung rate of change o yung pagbago ng temperature ng body once na na-expose siya sa iba't ibang temperature or after given time. Okay? So, in formula, yung rate of change ng temperature, so rate of change daw ng temperature with respect to time is proportional daw siya, okay? Proportional siya sa difference nung temperature ng body tsaka nung medium, okay? So, ganyan ang itsura niya, okay? Then from algebra, pag nakakita tayo ng proportionality, pwede natin siya maging equal sign by introducing a constant of proportionality. Okay? So, ibig sabihin, magkakameron tayo ng T. Okay? Equal sa K times T minus M. Okay? So, ibig sabihin, ito yung differential equation concerning Newton's law of cooling. Okay? Pero kailangan, before we proceed, lagyan natin ng negative sign dito sa unahan niya. Okay? So bakit? Kasi since temperature yung pinag-uusapan natin, ibabalik lang sa temperature. Mas mataas na temperature, ibig sabihin, mainit siya. Pag negative, ibig sabihin, malamig. No? Or pag decrease ng value, Negative siya. So, kailangan natin lagyan ng negative sign dito to indicate na cooling siya. Okay? Nagigets ba yun? Kasi pag hindi natin nilagyan ng negative sign, tapos pag sinolve natin yung differential equation na yan, makukuha natin is a value na dapat para sa cooling na temperature. Pero makukuha nating value is masyadong mataas. Kapag tinignan natin halimbawa sa thermometer, hindi ma-justify na malamig yung body na yan. Okay? So like for example, sa temperature ng body, halimbawa 37 degrees, sabihin natin lumamig, no? Ibig sabihin bumaba yung temperature mo, pero ang na-compute mo is naging 42. Hindi mo naman sasabihin na yung 42 degrees na body temperature mo ay ano, wala kang sakit, di ba? Ibig sabihin niya, mataas ang temperature mo, ibig sabihin may sakit ka, no? May lagnat ka. Kaya ganun yung ano niya, yung ideology niya, no? Kaya kailangan mag-introduce ng negative sign dun sa unahan ng equation o yung constant of proportionality natin. Okay? Pero pag tinatanong yung value ng K is always positive. Okay? Basta pag kinonstruct nyo lang yung differential equation niya, meron siyang negative dun sa unahan niya to consider na yung sinosolve natin is yung change ng body to a lower temperature or cooling. Okay? So kung yan yung equation natin, paano natin masasolve yan? So, i-rewrite ko dito. So we have dt over d small t is equals to negative k t minus m. Okay? Para ma-solve natin yan, pwedeng gawin natin is um, i-ano natin separable equation. So dt, divide natin both side by t minus m. Then si dt, multiply natin doon sa kabila. Okay? Then once na-satisfy na natin yan, pwede na tayo mag-integrate. So pag kinuha tayo integration nito, so si m dito is treated as constant kasi kung siya yung temperature ng surrounding, hindi nagbabago yung temperature niya o yung control yung control temperature natin. So ibig sabihin si m is constant. So si t lang yung variable natin dun sa denominator natin. Okay? So pag kinuha natin yan, this will be ln t minus m is equals to negative k t plus c. Okay? And then, para ma-eliminate yung ln, pwede natin erase sa e, both side of the equation. So pag ni-erase natin ng e, okay, this will be now t minus m is equals to e negative kt. Then since ito is naka-addition yung exponent niya, pwede natin siyang hiwalayin, magiging siyang multiply ng e raised to c. Okay? But e raised to c, hindi mo si c is any value. So, ibig sabihin pwede natin ito i-represent as c na lang din. Okay? So, our final equation now will be t minus m is equals to e negative kt times c. So, yung c pwede natin lagay dito sa harap. Okay? So, this now will be your equation para mahanap mo yung temperature ng body. Okay? So, magagamit mo yan, equation na yan kapag may mga given situations ka para ma-solve mo yung hinahanap dun sa problem. Okay? So, basta pinakita ko lang na ito yung general equation kapag pinag-uusapan natin Newton's law of cooling. Okay? So, maliwanag po ba dito sa part na to? Or do you have any questions so far? Before we proceed sa example. Okay? May question kami sa pasilan? Wait lang naka-mute pala yung sound ko. Okay? May question kami sa pasilan?
Wala po, sir.
Okay, okay.
Nalimutan ko lang po i-mute.
Okay, okay. Naka-mute pala yung sound ko kaya wala akong naririnig. Okay, sorry. Sige, sige. So, proceed na tayo sa example. So, let's have our first example. So, a 5-pound roast. So, ibig sabihin, yung turkey roast no, sa ibang bansa, initially at 50 degrees Fahrenheit, is put into a 375 degrees oven at 5 p.m. It is found that the temperature of the roast is 125 degrees Fahrenheit after 75 minutes. Okay? When will the roast be 150 degrees Fahrenheit? Okay? So, yung scenario natin is meron tayong turkey na lulutuin natin sa oven. Ngayon, yung initial na temperature ni turkey is 50 degrees Fahrenheit. Ngayon, ang pinaka-control environment natin ngayon is si oven, no? So kung si oven yung control natin, pwedeng sabihin natin yung 375 degree Fahrenheit, ito yung value ng temperature ng medium natin. So ito yung M natin. Okay? And then, itong 50 degrees Fahrenheit, ito yung tinatawag nating temperature niya initial, no? So pwede natin siyang tawagin na T sub O. Okay? So, ibig sabihin, at the start nung problem natin, yun yung temperature niya. Okay. Then after, it is found out that the temperature nung turkey natin on the roast is 125 degrees Fahrenheit after 75 minutes. So, ito yung temperature niya. So, 125 degrees Fahrenheit kapag ang time natin ay 75 minutes. Ngayon, ang question natin is, kailan siya magiging 150 degrees Fahrenheit? So, kailan siya iinit hanggang 150 degrees? So, temperature is 150 degrees Fahrenheit. Ang question natin is, kailan mangyayari yan? Okay? So, in solving this kind of problem, the first thing is to eliminate nyo muna yung mga arbitrary constant nyo dun sa equation na nakuha natin. Okay? So again, babalikan ko muna. So, nakalculate natin dito ng formula natin for Newton's law of cooling is T minus M is equals to C raised to negative KT. Okay? So, T minus M is equals to C negative KT. Okay? So, kung consider natin yung initial, so pag sinabi initial, yung time natin is 0, ano ang temperature natin? 50 degrees Fahrenheit. Okay? So we can use this para makuha natin yung value ng C. Okay? Substitute natin sa formula. So we have 50 degrees Fahrenheit is equals minus yung medium natin is 375 degrees Fahrenheit is equals to C E. Okay, wala tayong value ng K. Pero i-multiply natin siya ng T. So times 0. So ibig sabihin E raised to 0 or ito is equivalent na sa 1 or any number raised to 0 is 1. So ibig sabihin ng value ng C natin is equals to negative 325 degrees Fahrenheit. Okay? So nakuha na natin yung value ng C. So mula dun sa general equation natin, magkakameron na tayo ngayon na equation na 325 E negative K T. So ibig sabihin nakuha na natin yung value ng C mula dun sa initial value problem natin, yung initial values na meron tayo. So ibig sabihin itong equation na to, no? Itong equation na to, ito yung first equation. Itong second equation na nakuha natin is magagamit natin siya para ma-calculate naman yung value ni K. So paano natin ma-calculate yung value ni K? By considering yung given natin. So meron tayong isang given na given yung time, tapos given yung temperature at a certain time. Okay? So ito yung time niya is 75 minutes, then yung temperature niya is 125 degrees Fahrenheit. So yun yung tatry natin is i-substitute dun sa equation number 2 natin. Okay? So kapag T is equals to 75 minutes, ang temperature daw natin is 125 degrees Fahrenheit. So substituting that to equation number 2. So 125 degrees Fahrenheit minus 375 degrees Fahrenheit is equals to negative 325 degrees Fahrenheit E negative K. Then yung time natin is 75 minutes. Okay? Then, para ma-calculate yan, so minus natin yung 375 sa yung 120 minus 375. Okay? Tapos, para ma-isolate yung K, 375. So, that is negative 250. Tapos, pwede natin both side i-divide ng 300, negative 325. No? Kung matitira dito sa kabila is E, negative 75K. Okay? So, in minutes yung unit nun. Then, para ma-isolate yan, pwede natin lagyan ng ln both side. So, that will be ln 250 over 375. Nag-cancel out na yung unit, no? Is equals to lne, tapos naka-reach siya sa exponent, mabababa na yung exponent niya. Okay? So, therefore, para ma-solve si K, divide natin both side by negative 75. So, K is equals to ln ng 250 over 375 divided by negative 75. Okay? Pag sinolve nyo sa calcu, ln 250 over 375, sorry, 325 lang pala yun, 325. Okay? Tapos divide mo ng 75, negative 75. Your value is 5.406 times 10 raised to negative 3. So, note nyo na positive yung value na nakuha natin K kasi kinonsider na natin sa equation natin na naka-negative yung value ng K natin. Ano? So, para consistent lang tayo. So, meron na tayong value ng K. So, therefore, since constant of proportionality yan, ibig sabihin, yung equation 2 natin will now be T minus M is equals to negative 325 E raised to negative 5.406 times 10 to the negative 3 T. Okay? So, yung nakuha yung bagong equation na to, this will now be your kumbaga, equation na pwede mong i-apply sa any condition. Okay? So, ibig sabihin, if given ka ng time, malalaman mo na agad yung temperature niya. Kaya pag given ka ng temperature, malalaman mo agad kung kailan niya ma-reach yung temperature na yun. So, ito yung pinaka
Sir, may tanong po
useful
ako.
equation, no? Yes?
Saan po nanggaling yung 375?
3
Akala ko po
set
325.
325 siya, 325. Ito. Itong nasa ilalim nito ay 325. Binago ko na dito sa kabila. Nga, ayusin ko lang yung sulat. Okay. Okay. Okay, if you check, dapat 325 over 325. Okay? Yung na-input ko sa calcu ay 375 pa din. Okay, so yung value is not 5.46, rather siya ay 3.498. Okay? 3.498. So ito is dapat yun din. Okay? So thank you. So itong equation number 3 natin is now your equation for any given time tsaka temperature. No? So, try nating i-solve na yung pinaka-question natin. Tinatanong ngayon is, kailan magiging 150 degrees Fahrenheit yung temperature ng turkey natin or ano yung after ilang minutes, no? Okay. So, given yung last natin, equation number 3, T, T minus M is equals to negative 325 E negative 3.498 times 10 to the negative 3 T. So, ang pinapanap sa atin ngayon, kailan magiging 150 degrees Fahrenheit yung turkey natin. Okay? So, substituting lang dun sa third equation natin. Okay, so 150 Fahrenheit minus, yung control natin is 375. So, negative 325 E negative 3.498 times 10 to the negative 3 T. Okay? So, this will be 150 minus 375. That's negative 225 degrees Fahrenheit over negative 325 degrees Fahrenheit is equals to E negative 3.498 times 10 to the negative 3 T. Okay? Cancel out yung unit, cancel out yung negative sign. Para ma-simplified si E, gagawin natin ln parehas, both side. So this will be ln of 225 over 325 is equals to negative 3.498 times 10 to the negative 3 t. Then dividing both side by yung value ng k natin, 3.498 times 10 to the negative 3, cancel out. So yung time natin will be ln 225 over 325 divided by negative 3.498 times 10 to the negative 3. That is 105.124. Again, yung unit ng gamit natin kanina is in minutes. Okay? So, pag sabihin, after 105.124 minutes, magiging 150 degrees Fahrenheit na yung turkey natin. Okay? So, kung halimbawa pinapa-specify kung ilan hours, so divide mo ng 60. So, you will have 1.752 hours. So, kung mas specific, yung 0.752 times mo ng times mo ng 60. So, mangyayari after 1 hour and 45.12 minutes. Okay? So, ito yung pinaka-conversion niya kapag exact time yung binibigay. Pero since balikan natin yung problem, may given siyang oras at 5 p.m. Okay? So, siguro kapag sinabi niyang when, kailangan niyang sagot is yung time mismo, no? Since nagbigay siya ng oras na 5 p.m. Kasi kung halimbawa, sinet mo lang yung oven mo, tapos kailan mo babalikan para alam mo kung kailan maluluto, no? Sabihin natin yun yung time para maluto siya. So, ang pinakasagot natin now will be yung 5 o'clock natin plus natin yung itong 1 hour and 45.12 minutes natin, ano? So, therefore, ang sagot natin will be 6:45 p.m. Okay? So, at 6:45 p.m., ibig sabihin, 150 degrees Fahrenheit na yung roast natin. Okay? Question for problem number 1. Okay? Sana malinaw talaga sa lahat, no? So, kung scientific calculator yung gamit nyo, what I suggest is kapag nakuha nyo yung value ng K, i-store nyo siya sa isa sa mga letter. Halimbawa sa A, i-store nyo siya para mas exact yung value na magamit natin. Ano? Kasi ang problema dyan is yung pagra-rounding off ng numbers. May effect kasi yun dun sa magiging final answer mo. Okay? So, kung mas exact yung gagamitin yung value ng K, mas makukuha natin yung exact time. Lalo't LN ang pinag-uusapan natin, naka-logarithmic siya. So, every decimal point matters. Kaya, yan. Okay? So, that is example number 1. Let's go to example number 2. So yung tanong natin, at 12 midnight, with the temperature inside the warehouse at 70 degrees and the outside temperature at 20 degrees Fahrenheit, the furnace breaks down. 2 hours later, the temperature in the building has fallen to 50 degrees Fahrenheit. Determine when the temperatures in the warehouse falls to 40 degrees Fahrenheit. Okay. So, kailangan i-analyze nyo muna yung problem, no? So, may warehouse tayo, tapos meron sa labas. So, considering siguro na um, snowing to, no? Kasi mas mababa yung temperature sa labas. So, warehouse, meron tayong warehouse. So, sabi, yung temperature dun sa loob ng warehouse, 70 degrees Fahrenheit. Okay? So, and then, outside temperature natin is 20 degrees Fahrenheit. Ano ba yung nangyari? Nasira yung furnace. Yung furnace is yung nagge-generate ng heat. Kumaga heater para dun sa warehouse. Okay? Kasi dyan nagbe-burn tayo ng mga iba't ibang material, no? Kumbaga para mag-generate ng heat, usually wood, no? 2 hours later daw, yung since walang gumaganang heater dun sa loob ng temperature, anong warehouse, bumaba yung temperature ni warehouse from 70 naging siyang 50. Okay? Tinatanong is, kailan magfo-fall ng 40 degrees? Kailan bababa pa siya ng 40 degrees? So, isang method sa pag-solve ng ganito is isulat nyo in chronological order yung nangyari. Ano? So, halimbawa, at time is equals to 0. So, ibig sabihin, wala pang changes na nangyayari or wala pang hindi pa nasisira yung furnace o yung at the start of the problem, ang temperature natin is 70 degrees. Okay? Then after 2 hours na mag-breakdown na siya, ang temperature natin is now 50 degrees Fahrenheit. Ang question is, kailan magiging yung temperature natin is 40 degrees Fahrenheit. Okay? Then dito, ang magiging medium natin ngayon o yung control natin is yung outside temperature natin. Okay? So, ang M natin dito is 20 degrees Fahrenheit. Okay? Since given yung oras na 12 midnight, ang hinahanap na final answer natin ulit is oras sa clock din. No? Okay? So, let's say for example, hindi mo alam yung general equation. So, babalik ka lagi na yung temperature ng body, yung rate of change niya is always proportional sa temperature ng body minus dun sa medium niya or yung sa surroundings niya. Okay? Then katulad ng ginawa natin kanina, that will be, meron tayong proportionality. So we can introduce constant of proportionality. That will be K, T minus M. Pero since Newton's law of cooling tayo, again, may negative sign tayo dito. Okay? Then pag sinolve natin yung differential equation na yan, by using separation of variables, makukuha natin is T minus M is equals to C E negative K T. Okay? Which is ito yung general equation natin. Okay? So, from the general equation, kailangan identify natin yung value ng C at ng K muna. No? So, usually, ang unang lagi na-solve kapag may initial value problem o yung from the start of the event is yung value ng C natin. No? Kasi, laging time is 0. So, pag alam yung time is 0, magiging exponent lagi nung E is 0. So, any number, any variable raised to 0 is always equals to 1. Okay? So at initially, 70 degrees Fahrenheit siya minus yung control natin na 20 degrees Fahrenheit is equals to C E negative K times 0. So this will be equals to 1. So this will be 50 degrees Fahrenheit is equals to C. So our first equation now will be T minus M. Or pwede nyo ilagay na din yung M, no? Kasi since di naman magbabago yung value ng M. Is equals to 50 degrees Fahrenheit E negative K T. Okay? So ito yung second equation natin. Yung first equation is yung general equation. Ito yung second equation natin. Okay? Next is apply natin yung isang scenario natin na kapag T is equals to 2, ang temperature daw natin ay 50 degrees Fahrenheit. Okay? So applying yung second equation, so 50 minus 20, so degree Fahrenheit yan, equals to 50 E negative KT. That will be 30 over 50 equals to E negative K. Yung time natin is 2. Okay, so ayusin ko lang to. So ito ay 2. So ito magiging 2K. Okay, and to simplify, ln natin both side. So we have ln, this will be 3 over 5 is equals to negative 2K. Para makuha natin si K, divide natin by negative 2. So K is equals to ln 3 over 5 divided by negative 2. So we have 0.255. Okay? So pwedeng 3 decimal places or again, para mas exact, i-store niyo yung mismong value niya sa calculator. So yung pag-store is pindutin niyo shift, tapos yung RCL, tapos yung mga letter, yung ABCD, mamili lang kayo ang bawal letter A, tas equals. Okay, may store na yung value niya. Okay, so may value na tayo ni K. So makukuha natin si third equation natin. So yung third equation natin will now be T minus 20 degrees Fahrenheit is equals to 50 degrees Fahrenheit E negative 0.22255 T. Okay, so this will now be your formula for any condition. Okay. Okay, so tinatanong ngayon is yung last condition natin, kailan siya magiging 40 degrees Fahrenheit. So, T is equals to unknown. T is equals to 40 degrees Fahrenheit. So, we have 40 degrees Fahrenheit minus 20 degrees Fahrenheit equals to 50 Fahrenheit E negative 0.255 T. Okay, so this will be 20 over 50 equals to E negative 0.255 T. Okay, so ln natin, we have ln of 2 over 5. Tapos i-recta ko na, so same lang yung ginagawa kanina. 0.255 equals sa T. So yung T natin is equals to ln 2 over 5 divided by negative nung K natin. We have 3.5.87. So yung unit natin is 2 hours, no? So hours to, so 2 hours. Okay? So kung after midnight yan, yung 0.587 natin, convert ko lang in minutes. So ibig sabihin, siya ay 3 hours and 35.22 minutes. So yung time na kailangan natin is at 3:35 AM. Okay? So yan yung oras kung kailan magiging 40 degrees Fahrenheit yung temperature ng warehouse natin. Okay? Question for number 2. Okay? So madali lang naman siya, no? Kasi may procedural naman yung kanyang solution. Basta marunong ka mag-identify ng given. Hindi ka magkakaproblema dyan. Okay? So down to our last example. So a body of temperature 80 degrees Fahrenheit is placed in a room of constant temperature 50 degrees Fahrenheit at time t is equals to 0. And at the end of 6 minutes, the body has cooled to a temperature of 75 degrees Fahrenheit. Determine the temperature of the body as a function of time for t greater than 0. Then what is the temperature of the body at the end of 60 minutes? Okay. So temperature ng body, 80 degrees Fahrenheit siya. So constant temperature, 50 degrees Fahrenheit. So ito yung M natin. So at time is equal to 0, ito yung condition natin. So T is equal to 0. Temperature natin is 80 degrees Fahrenheit. Next, after 6 minutes, yung temperature natin ngayon is 75. So 6, temperature natin will be 75 degrees Fahrenheit. Determine yung temperature of the body as a function of time for t greater than 0. So, ang ibig sabihin nito is yung equation number 3 natin na kinukuha, no? So, yun yung kailangan natin kunin. Yun yung pino-point out niya, no? Hanapin mo yung value ni t, yung value ng equation kapag for any value of t. So, t greater than 0. Okay? Kasi dito, once na ma-identify, magbigay ka ng time, halimbawa, after 150 minutes, makukuha mo na agad yung temperature. So, ito na yung working equation mo para dun sa problem na yan. Okay? So, yun daw yung kailangan kunin na una. Then, yung pinaka-last na tanong is, ano daw temperature ng body? Okay, temperature ang hinahanap. So, wala. T ang wala after 60 minutes. Okay? Solve muna natin yung yung pinaka-standard, yung specific equation natin for this problem. So, starting from the general equation, T minus M, negative. Ito ay C, E, negative KT. Okay? So, applying to. So, we have 80 minus yung M natin is 50. Is equals to C, E. This will be 0. So, it will be 1. So, C is equals to 30. Our equation now will be T minus 50 is equals to 30 E negative KT. Okay. This is 1. This is 2. Okay, next. So, applying yung condition natin na T is equals to 6 minutes for temperature of 75 degrees. So, so value natin is 75 minus 50 is equals to 30. E negative K times 6. Or this will be 25 over 30 equals to E negative 6K. So ln both sides. Value of K will be ln 25 over 30 all over negative 6. So yung K natin will be ln 25 over 30 divided by negative 6. So we have 0.0304. Okay? So yung value ng equation natin now will be T minus 50 is equals to 30. E is to negative 0.0304 T. Okay? So ito yung hinahanap dun sa first question natin. No? So hinahanap yung kanyang value for any given time. Okay? Next is yung last na tanong. Temperature natin kapag after 60 minutes. Okay? So substitute mo lang. Minus 50 is equals to 30. E negative 0.0304 times 60. So T, transpose mo lang yung 50 dun sa kabila. Plus 50. So yung temperature natin will be 30. Then E raised to negative yung value ng K natin times 6 plus 50. So yung answer natin is exactly 75. Tama ba? Times 60, sorry. Hindi times 6, times 60. No? So this should be 60. So after 60 minutes, our temperature will now be 54.845 degrees Fahrenheit. So this is now our final answer. Okay? Any question for Newton's law of cooling?
Sir,
Yes.
always po Fahrenheit yung gagamitin.
Hindi naman. Depende sa given sa problem. So yung nakuha kong problem kasi mga naka-Fahrenheit lang, no? Pero kung halimbawa dito sa Pilipinas, siyempre Celsius tayo.
Po.
Pero wala namang, buti hindi
Pero
naman
pag na,
ano yan?
ibig sabihin po, if ever lang naman po magkaka-Celsius, di na po kailangan i-convert sa Fahrenheit.
Hindi na naman. Pero kung halimbawa, sa multiple choice problem siya, halimbawa, then nakita nyo Fahrenheit yung given, pero sa multiple choice naka-Celsius siya. So, you have to know kung ano yung conversion ng Fahrenheit to Celsius. No? Pero si Calcu naman, meron
Okay
din
po,
siya.
sir.
Meron din siyang direct conversion. Kung marunong kayo yung conversion function ni Calcu. No? So, meron din siyang direct conversion ng Fahrenheit to Celsius. Okay?
Okay po, sir. Thank you po.
Okay. So, no more question for Newton's law of cooling. Okay. Next, we now go to growth and decay. Okay. So kung medyo madali yung kay Newton's law of cooling, sa growth and decay, mas pinadali. Okay. Kasi ang sinasabi lang kay growth and decay, the rate of change of a population. Okay. So population lang yung nilagay ko pero this can be a substance, a bacteria. So lahat ng pwedeng mag-grow and mag-decay, no? Is proportional to the amount of the population present. Okay? So, ibig sabihin lang niya, yung rate, halimbawa sa population tawagin kung P, no? So, yung rate of change niya with respect to time is proportional daw dun sa ano niya, amount of population. So, pag kinuha natin yung constant of proportionality niya, that will be equals Kp. Okay? Then, para ma-solve natin, same lang din, separation of variables tayo. So, dp over p is equals to k dt. Then perform natin integration. So, that will be ln of p is equals to k t. Tapos raise natin e both side. That will be p is equals to e k t. Okay? So, ito yung general equation for growth and decay. Okay? Pero may rule of thumb lang siya, no? So, yung sa value din ng k, no? So, pag halimbawa, pinag-uusapan natin is growth, laging positive yung sa k. Tapos pag negative siya, siya ay decay. Okay? So, pag halimbawa, hindi pag-multiply ng number ng isang substance o population yung pinag-uusapan natin, yung general equation natin will be negative e, negative kt. Okay? So, ibig sabihin nito ay decay. Okay? So, ito ay growth. Okay? Malinaw tayo doon?
Sir, wala pong C.
Sorry. Oo nga, no? Thank you. So, meron tayong C. So, may C tayo dito. So, yung sagot natin dapat may plus C dito. May plus C yung exponent, no? Sorry. Thank you. So, that will be times, okay? Yeah. Okay? Okay, so apply na natin agad sa example. So, yan. So, a culture. So, pag culture usually pertaining sa bacteria yan, ano? A culture initially has a number of n sub O of bacteria. So, ibig sabihin, initially, laging ang pertaining sa T is equals to 0. Okay? So, sulatin natin is T is equals to 0. Ang population natin So, yung number natin, tawagin ko na lang na n is equals to n sub o. Tapos, wait, parang may kulang sa problem, no? Check ko lang yung problem. Naputol. Okay, naputol pala yung problem. So, nakalagay sa problem, a culture initially has a number and sub of bacteria at t is equals to 1 hour. Yung number ng bacteria present is now 3 halves ng initial. Okay? So, if the rate of growth is proportional to the number of bacteria present, so ibig sabihin yung formula natin kanina, no? So, n na lang yung gagamitin ko ngayon. Proportional dun sa number present. So, ibig sabihin makukuha mong solution ng differential equation is same lang din, ano? N is equals to CEKT. Okay? Determine the time necessary para yung number daw ng bacteria natin is mag-double. Tapos yung isa is para mag-triple. Okay? So, dalawang question yung hinahanap. So, same lang din nung kanina sa Newton's law of cooling. Dun sa initial na given, makukuha mo yung value ng C. Dun sa isang condition na may given na time tsaka population, makukuha natin yung value ni T. Okay? So, substitute natin dun sa first sa general equation natin. C, E, K, T. So, positive yung K kasi growth yung pinag-uusapan natin. Ano? Rate of growth. Okay, so yung N natin at initial is N sub O is equals to C, E raised to 0. So, this will be 1. So, C is equals to N sub 0. So, yung equation natin will now be N is equals to N sub 0 E K T. Okay? So, ito yung first natin, ito yung second natin. Now, apply natin yung second condition natin. So, kapag T is equals to 1, ang N natin is 3 half ng NO. So, E K times 1. So, this will be cancelled out. So, para makuha si K, ln natin both sides. So, we have ln 3 halves is equals to K. So, K natin is equals to 0.405. No? So, yung formula natin now will be N is equals to N sub O E 0.405 T. So, na yung pinaka-specific equation natin for the problem. So, kapag yung tinatanong sa atin, kailan siya magiging double, no? So, substitute nyo lang 2N sub O. So, gusto N sub O, E, 0.405 ng T. So, magka-cancel out yung N sub O. Then, para mawala si E, ln 2 over 0.405 is equals to T. So, yung T natin is equals to ln 2 all over yung value ng K. So, we have 1.771. So, ito is unit niya is in minutes. Okay? So, ito yung first answer natin. The next is kapag nag-triple siya. No? So, applying lang yung same cancellation, pinaka-formula natin will be ln 3 over 0.405. So, yung time natin now will be ln 3 over yung value ni K. So, after 2.71 minutes. Okay? So, ganyan po isolve yung para sa growth. Question? Okay? Next. So a certain radioactive material is known to decay. Okay? Note the term decay at a rate proportional to the amount present. So gawin ko na lang na N na lang din yung representation ko ng radioactive material, no? So ibig sabihin, dN over dt is equals to C E negative KT. Wala na pala to. So ito ay N, no? Para sa general equation natin. So negative lang yung K. Then if initially, okay, sabihin T is equals to 0, ang N natin is 50 milligrams. Tapos after 2 hours, okay, 2 hours, yung N natin is nag-loss ng 20% ng original mass. So kung 50 milligrams siya, nag-loss ng 20%, ilan na lang natitira? 80%, no? So kunin yung 80% ng 50, that is 40 milligrams. No? So 80% of original. Okay? Next, pinapahanap is find the expression of the amount present remaining at time t. So ibig sabihin, yung third equation natin kanina. Then yung next is the mass of the material after 5 hours. Ano yung mass niya? Then at time which the material has decayed to 1/2 of its original mass. Okay? So yung time kung kailan magiging yung N natin is equals to 1/2 ng original mass natin na so 25 milligrams. So 50%. Okay? So pag sinolve natin ngayon, so N is equals to C E negative KT. So initial muna tayo. So 50 is equals to C E raised to 0. So 1. So ang C natin is 50. So equation natin will now be 50 E negative KT. So ito yung second equation natin. First equation. Then applying yung given natin. So 40 milligrams is equals to 50 E negative K times 2 or K is equals to ln of 4 over 5 all over negative 2. So yung makukuha natin yung value ni K is 0.112. Okay? So yung new equation natin will be N is equals to 50 E negative 0.112 T. Okay? So ito yung unang hinahanap sa atin, no? Yung letter A. Next is yung kung kailan after 5 hours ilan yung value natin. So ang N is equals to 50 E negative 0.112 times 5 hours. Okay? So using your calculang, E raised to negative times 5. So yung value natin is 28.622 milligrams. Okay? So ito na lang yung natitira after 5 hours. Then yung last na question sa atin is kailan siya magiging half o 25 milligrams. No? So kung i-analyze nyo, pag 5 hours, 28.622 siya milligrams. So, kailangan pa niya ng 3.622 na pagbaba para maging 50%, no? So, dapat yung sagot mo is more than 5 hours, no? So, substitute natin ngayon do sa given. So, 25 milligrams is equals to 50 E negative 0.112 T. Okay? So, applying lang yung logarithmic natin. T is equals to ln ng 1/2 over negative 0.112 or yung time para maging half na lang siya, okay, is after 6.19189, okay, pwedeng 189 hours. Okay? So ito yung answer natin for the last question. So which is correct, which is after siya ng 5 hours, no? So beyond 5 hours, tsaka siya magiging 50%. Okay? So ito yung solution for number 2. Any question? Okay? So dito sa letter C, 'di ba pinano niya half of its mass. So baka may encounter lang kayo ibang problem. Yung ibang term sa ganyan is pag sinasabi yung half of its mass. So minsan tinatawag siyang half-life, no? So may mga problem na ang term na gagamitin niya is hindi yung half of its mass. Gagamitin niya is halimbawa at what time is the half-life of the bacteria. Pag sinabing half-life, i-divide nyo lang by half yung original mass niya. Okay? So please take note of that. Okay? So half-life yung tawag. Then, let's proceed sa last example natin. So mali na naman ang... Ba't kaya lumaki yan? Okay? So, nambago yung size. Pero yung problem dun sa last is, basahin ko na lang, no? Hanapin ko lang. Okay? So, nakalagay, in a certain culture of bacteria, the rate of increase, okay? Rate of increase tayo, so ibig sabihin may growth tayo, is proportional to the number present. So, yung N natin is equals to CE positive KT. Okay? Yung unang condition, if it is found that the number doubles in 6 hours, okay? So, T is equals to 6. Ang N natin is double nung initial natin. Pero hindi natin alam ang initial, pero pwede kong sabihin na N sub O na lang. No? So, ibig sabihin, pwede kong ilagay, bako lang to. Pwede ko ilagay na pag sa initial time, since unknown naman sa atin yung initial na number ng bacteria, pwedeng variable na N sub O na lang. So, parang pertaining sa initial, no? N sub O. After 6 hours, nag-double siya. Ang tanong, how many may be expected at the end of 18 hours? Okay? After 18 hours, ilan na siya? Then, next nakatanong, if there are 10 raised to 2 at the end of 4 hours, so ito yung other condition. If after 4 hours, ang value ng N is equals to 10 squared or 100, tapos at the end of 8 hours, ang N daw is 8 times 10 squared. How many were there in the beginning? So, ilan yung value niya in the beginning, no? So, ibig sabihin, isang problem siya with different conditions, no? Okay? So, yung first condition natin, ito yung mga given natin. Then sa second condition, yun yung given natin. Okay? So, solve na muna natin. So, try ko i-solve dun sa taas na part na lang yung mismong problem natin na una. Okay? So, using yung initial value natin, so N sub O. Okay, so N sub O is equals to C E K times 0. So, this will be 1. So, C is equals to N sub O. Yung formula natin will now be N is equals to N sub O. Tapos, E K T. Okay? Then, kapag nag-double daw yung initial value, at 6 hours, no? Makukuha natin yung value ni K. So, K is equals to ln ng 2 over 6. Okay, so ln 2 over 6 is 0.116. Okay? So yung bagong equation natin na will be n is equals to n sub o e 0.116 t. Okay? So tinatanong after 18 hours, ano yung number ng bacteria? So from the original na n sub o, 6 times yung time natin na 18 hours, n is equals to, so pwedeng i-multiply mo na lang is yung exponential part kasi wala tayong value ng n sub o. So after 18 hours, siya ay magiging 8 n sub o. Okay? So ibig sabihin, siya ay magiging times 8 nung initial value niya. Okay? So yun yung para sa first part. Okay, yung sa A. Yung sa B, okay? So given tayo ng dalawang condition. Okay? So pinapahanap yung value ni initial. Okay? So anong gagawin natin doon? Since meron tayong given na pwedeng gawin natin si n dito is gawin natin n sub o din muna, no? Okay? So kung gagamitin natin yung original kanina na formula, n is equals to c e k t. Kung titingnan natin yung initial, makukuha natin na si c is equals to n sub o. So yung formula natin will be n sub o e k t. Okay? Tapos magkakameron tayo ng dalawang condition. Yung isa, ang value ng n natin, 10 squared is equals to n sub o e k times 4. Okay? So, equation number 1 natin to. Tapos yung isa is 8 times 10 squared n sub o e k times 8. Ito yung equation number 2 natin. So, makikita nyo, we have two equations, two unknown. Ang unknown natin ay si k tsaka si n sub o. So, para ma-solve yan, pwedeng mag-ano tayo, elimination or substitution. So from equation 1, gawin natin n sub o is equals to 10 squared over e 4k. Okay? Then substitute natin yan doon sa second equation. So we have 8 times 10 squared is equals to 10 squared over e 4k times e 8k. Okay? So ito magka-cancel out. Then kapag naka-divide yon, since parehas sila ng base, magiging 8 is equals to e 8k minus 4k o equals sa e raised to 4k. So para makuha si k, equals yan sa ln of 8 over 4. So ln of 8, divide mo ng 4 is 0.520. Okay? So kung may value ka ni k, pwede mo makuha si initial na yun yung hinahanap natin. So 10 squared over e 4 times yung k natin na 0.520. So value natin ng initial will be 10 squared all over e raised to yung value ng k natin. So initial natin is 59.46. Okay? So yun po. Yun ito yung magiging final answer natin. So anong bang unit na binigay dito? So bacteria tayo. So ano bang ginagamit na unit sa bacteria? Okay. Check ko lang yung problem kung anong ginamit niya. So ginamit niyang unit sa number is wala. Hindi niya ni-specify. Okay? So this will be our answer. Okay? Any question po?
Sir,
Yes.
hindi niyo po ata nasama yung 4.
Yung 4 saan? Doon sa LN?
Hindi po yung e raised to 4 po.
E raised to 4. Wait, check ko lang. So, 10 squared all over E. Oo. Hindi ko na multiply ng 4 yung exponent. Okay. Thank you. So, this should be 25 over 2, no? So, 12.5. Okay. So, ibig sabihin ang initial value natin is 12.5. Thank you. Okay. Okay. So, okay ba tayo sa growth and decay? Okay. So, if we don't have any more question, this ends our lecture for today. So, that is our two method or two applications for ordinary of order 1 or differential equation of order 1. So meron lang tayong remaining one method which is yung mixture. Sa mixture. Okay? Again, for those na hindi na abutan kanina nung opening, we will have a project, a final project for the subject. Yung final project na yun will be composed of 40 items na application problem. So you have to solve that 40 applications na yun. Concerning yan ng Newton's law of cooling, growth and decay, tsaka yung mixture. So sama-sama na siya doon, basta 40 items siya. Tapos kailangan, sasubmit nyo siya sa akin ng soft copy na naka engineering lettering ninyo. Okay? So, kailangan i-scan nyo yung gawa nyo, no? So, wag pong gamitin yung method na ginagawa nyong na font yung lettering nyo, no? So, ma-identify ko naman yan kung yan is engineering lettering na freehand or yung gamit sa computer na kino-convert yung handwritten nyo as font o handwriting nyo as font. Okay? So, thank you guys for attending this class. So, see you again next time. Okay? Thank you.
Thank you, sir.
Thank you po.